Okay, hey guys, we're gonna start our next unit. This is your 2-1. 2-1 is about the distance between 2 points, finding the distance between 2 points, and about the midpoint, finding the middle of a line. So before we get started, chapter 2, chapter 3, our unit 2 is going to be a lot of graphing. So just a quick remember when. This is my y-axis, that line that goes up and down. The line that is horizontal and left to right is my x-axis. And when we're graphing, we always move left and right, then up and down, right? We're plotting coordinate points. The first point is always the x, and the second point is always the y. So if I were to have this point right here, my x is 1, 2, 3, so I would have a 3. And my y is up 1, so I would have a 1, right? Of course, this point right here in the middle is called the origin. That is the coordinate point, 0 on x and 0 on y. When I cross these two number lines, it divides my plane into 4 sections, and each of those sections is called a quadrant. Right? And this in the upper right-hand corner, I'm on the right side of x and on the top side of y. So everybody is positive. This is my quadrant 1. And x is positive and y is positive because I'm on the right of that number line and the top of that number line. However, if I come over here to quadrant 2, now I've moved over to the left side of my x-axis. So here in quadrant 2, my x is going to be a negative number and my y will be a positive because I'm still on the top side. Coming around just like a C. 1, 2, 3, quadrant 3. Now, I'm not only on the left, but I'm on the bottom side of y. So over here in quadrant 3, the x is going to be a negative number and the y is going to be a negative number. Okay? And then I have quadrant 4. I'm back on the right side, so my x is positive and my y is negative because I'm on the bottom side. Okay? So, like this is positive, positive. 3, 1. Let's say I had this point right here. I'm on the left side of x, so that's a negative 1, negative 2, and a positive 1, 2, 3. Negative 2, positive 3. Here, down here in quadrant 3, I know everybody's going to be negative. I'm on the left and bottom. So left is negative and down is negative. Negative 1 on x and negative 3 on my y. Okay. How about over here in 4? So 1, 2 to the right. That makes x a positive 2. 1, 2 down. That makes y a negative 2. Okay. Just a little bit of remember when, because we're going to be using the graph in almost everything in chapter 2 and a lot in chapter 3. So you need to remember, refamiliarize with your coordinate plane. Okay, so the distance between 2 points. Well, if I have 2 points and they create a vertical line, let's see, this is negative 2, negative 1. Nope, I'm sorry, negative 2, positive 1, and negative 2, 1, 2, 3, 4, 5. All right, so if I want to know my distance, all I have to do is 5 minus 1, 4. 1, 2, 3, 4. Right? Distance is 4 units. Same thing if it's a horizontal line. I've got 1, 1, 2, 3, 4, 5. So this is 1, 5. And 1, 2, 3, 4, 5, 6, 7. 7, 5. All right, what's the distance of this line? Well, the 5's don't change, so that's just 7 minus 1 gives me a 6. Thing is when that line is slanted, I can't. So what am I going to do? One thing I could do, if I have it on a graph, is I could complete a right triangle. Why would I want to make a right triangle? Well, remember Pythagoras. A squared plus b squared equals c squared. And remember my legs, the A and B are the two shortest side, and the length, the distance that I want to find out is going to be my longest side. So I have 2 here, so I would say 2 squared, and 2 here, so I would say 2 squared equals c squared. So 4 plus 4 is equal to c squared. C squared is equal to 8, right? And remember, I don't want to know what c squared is. C squared would be the area of this square that would be formed out here, and I'm not really interested in that. I just want the distance of this line. So I need to find that out by taking the square root of both sides. So my distance of this line is going to be the square root of 8, and that's going to simplify. Don't forget to simplify if it can. Just like if you had a fraction that could be simplified, you do need to. So I would have the square root of 4 times the square root of 2. The square root of 2 is 2. So my distance between point A and B is 2 times the square root of 2, right? Okay, so what if I don't have a graph and a line, and I could draw me a triangle and count my sides? What if all I have is 2 coordinate points? Well, you have a formula, and the formula comes right out of a squared plus b squared. This is my legs, and this is my slanted line, my answer, my distance. So what's the last thing we do with the Pythagorean theorem? We take the square root, right? So we're going to start there. We got the square root. To get my 2 sides, my legs, I'm going to say x minus x. I'm going to subtract them. So I have x minus x, and instead of a squared, I put square that, right? Plus, same thing, y minus y squared. And all I'm doing is I'm subtracting my y minus y so I can find the length of this one the same way we did 7 minus 1 and 5 minus 1. I'm subtracting the y minus y to get the length of one leg, and the x minus x to get the length of the other leg. And that's where my formula comes from. I'm just going to follow it. Remember, first is always x, second is always y. X and y. So my distance between these 2 points, if I plotted them on the graph, how long would that line be if I connected it? Is going to be distance is equal to the square root. And it doesn't matter what area, what direction you go, because you're going to square it, right? So if I get a -3, it's going to be 9. If I get a +3, it's still going to be 9. Now, it's just good practices to always go in the same direction. So if I'm going to say -1 minus 2, squared plus, then I'm going to say 0 minus 4 squared. Okay? So far, so good. That's just our setup. Now it's just the math. Is equal to -2 minus, -1 minus 2, -3 squared. Remember those parentheses are important. Little side note, -3, no parentheses, is equal to a -9. -3, parentheses, squared is equal to a +9. Parentheses matter. Plus -4 squared. So -3 times -3, I have the square root of 9 plus the square root of 16 gives me the square root of 25, and my distance between these 2 points is going to be 5 units. Okay? And don't worry about the plus or minus because it's distance. So you can't have a negative distance, right? So it's just going to be a positive. All right, so try your 23 or your 25. Put your video on pause. Try working that one, and then come back and we'll do 26. So hopefully you did 25, and we're going to work 26. XY, XY, right? Distance. And you know what? I did 2 minus 4 the last time, so I'm going to go the other way. It doesn't matter. 4 minus 2, as long as you get the x's together and the y's together. Squared plus 2 minus, and be careful because this formula has a minus here, and this 3 has a negative. So what is that going to happen there? That's going to turn into a plus, right? So be careful of that. The minus belongs to the formula, and the negative on the value doubles it up, and that gives me a plus sign. All right, so it's equal to the square root of 2 squared, 4 minus 2 squared, plus 5 squared is equal to the square root of 4 plus 25 is equal to the square root of 29. Now 29 is prime, so that's not going to simplify down, so that's simply going to be your answer right there. Okay? All right, so remember, a right triangle fits into the Pythagorean theorem. If it is a right triangle, then a squared plus b squared will equal to c squared, right? So when they give you 3 points and they say, okay, do these 3 points make a right triangle? What you're going to do is you're going to find the distance between AB. So here is side AB, between AC, here's side AC, and BC. You need to find the distance between each of these points to create your 3 sides of your triangle. When you create the 3 sides of the triangle, you see, do they fit into the Pythagorean theorem? If it's yes, then you got a yes. If it doesn't, it doesn't. Sometimes it'll be one or the other. Don't think that just because it doesn't fit in, you have the wrong answer. That just means that it's not a right triangle. So AB, x minus x, -2 minus 12 squared. 5 minus 3 squared. Get my plus sign in there. All right, so now I have the square root of 14, negative 14 squared plus 2 squared. So that gives me the square root of 196 plus 4. So my distance of AB is the square root of 200. Now, because AB, the distance that I need to use that. That's not my answer. I need to use that to answer another question. So I'm just going to leave that alone. Leave it as it is. All right, now I'm going to find AC. So again, square root, negative 2 minus 10. X, I'm doing AC now. Squared plus 5 minus negative 11. Not negative 5, that's a positive 5. Squared. All right, so negative 2 minus 10 gives me negative 12 squared plus 16 squared. So that gives me 144 plus 256. So that gives me the square root of 400. Okay? All right, and again, this isn't the answer I'm looking for, so I'm going to leave it just as it is until I get all of my numbers. I'm not going to bother to take the square roots. All right, so BC, x minus x, square root, 12 minus 10 squared, plus 3 minus negative 11. Again, be careful. There's the minus from the formula and the negative on the number. And that's going to create an addition. So this is the square root of 2 squared plus the square root of 14 squared. And that's going to give me that 4 plus 196 again. So this is equal to the square root of 200. Now, I'm going to show an extra step, but we know that these are the two legs, right? Because they're the two smallest side. And what happens when you take the square root and square it plus the square root of 200 squared? Remember, a squared plus b squared equals square root of 400 squared. Well, those squares and those square roots cancel each other out. So this comes down to, does 200 plus 200 equal 400? Yes. So my answer isn't right because it's a yes. My answer is just yes because it does fit into the Pythagorean theorem. Okay? If you get a no, if it doesn't add up, these two legs do not add up to that hypotenuse, then that's fine. That's not a wrong answer. It just means that your answer is no. It's not a right triangle. Okay? That was your problem 34 out of the textbook. Why don't you try 33? Put the video on pause. Okay? All right. So let's try one more of those. I know they're a little bit long, but they're certainly not complicated. I need AB. Distance between A and B. Negative 6 minus 3 squared plus y minus y. 3 minus a negative 5 squared. Negative 9 and 8. So I have the square root of negative 9 squared plus 8 squared. All right, 81 plus 64. What is, I'm going to cheat. 181 plus 64, 145. So I have the square root of 145. And I'm going to leave it there because remember, that's going to get canceled out when I plug it into the Pythagorean theorem. All right, A, C. So I have negative 6 minus negative 1. Plus 3 minus 5. Okay, so the square root of negative 6 minus negative 1 is negative 6 plus 1, and that's going to give me a negative 5 squared. Plus 3 minus 5 is a negative 2 squared. So I have 25, and 4 gives me the square root of 29. All right, I got two sides. I've got the AB and the AC. Now I got to get my third side of the triangle, BC. So the square root of 3 minus negative 1 squared plus negative 5 minus 5 squared. All right, so that's going to give me a 4 squared, or 3 minus negative 1, negative 5 minus 5, negative 10 squared. So 4 squared is 16, 10 squared is 100. So now I have the square root of 116. So here's my two smaller ones. So this is my A, this is my B. And remember, if I say A squared, that's just going to be 29. If I say B squared, that's going to be 116. Now, will 29 plus 116 equal 145? Let's see. 29 plus 116 does equal 145. So again, what is my answer? Yes. These 3 points plotted on a graph connected would equal a right triangle. Okay? All right. Midpoint. Midpoint, just what it says. It's the point that's in the middle. So I have a formula, but I think before I do the formula, let's look at these 2 points right here. And I'm going to draw me a quick little graph. Get a little bit higher here on this one. All right, and I'm going to plot the point negative 2, 0. Left 2, y is 0, so I don't go up, I don't go down. 2, 4. 1, 2, 1, 2, 3, 4. Okay, so what I'm looking for is what point would be right in the middle of these 2 points. What's going to be centered? If I go up 2 and right 2, and up 2 and right 2, I can see that this point is going to be my center. This is my 2, 4. This is my negative 2, 0. What's this point right here? X is still on 0 and Y is on 2. So if I use my midpoint formula, my answer should be 0, 2. Formula. How do you get to the middle of something? You cut it in half, right? How do you cut something in half? You double it up and divide it by 2. Now, that's the only thing that can be a little bit frustrating or tricky about the midpoint formula is majority of the time you're always saying x minus x and y minus y. And on the midpoint is the time when you're going to say x plus x. And remembering midpoint is an addition. is a little bit tricky. So my x plus x, negative 2 plus 2, divided by 2. Negative 2 plus 2 is 0, divided by 2 is 0, right? And y plus y is 0 plus 4 divided by 2, and there's my 2. And there's my coordinate 0, 2, right? X plus x divided by 2, y plus y divided by 2. Remember, it is a midpoint, so it is a coordinate point, x and y. All right? Why don't you try 41, 39, I think it is one of those, before we move on and do 42. Just take a pause on the video. Okay? Hopefully you turned out well for you, and I am going to do x, y, x, y. X plus x. 2 plus 4 divided by 2. Y plus y. Negative 3 plus 2 divided by 2. Remember, it is a midpoint, right? So I would have 6 over 2 gives me a 3. Negative 1 over 2, negative 1/2. And there's my midpoint. Okay. Distance and midpoint, two formulas for 2, 1. Just get those formulas down in your head, and it gets a lot easier when you know them. All right? All right. Talk to you later, guys. Have a great day.